All right, so you've had some time to solve this problem. The first thing you're trying to do is determine the ratio of hydrogens in this compound. And so we look at the integration trace, we see a value of 2, 3, and 3. So that's our ratio. 2 to 3 to 3. Now, in order to determine the molecular formula, it's going to be useful to find the total hydrogens from this ratio. So if we sum these up, we find that we would need to have 8 hydrogens. And when we consider the empirical formula here, C2H4O, in order to get to 8 hydrogens, we're going to need to multiply that entire thing by 2. So we would get C4H8O2 as our molecular formula. From there, you were asked to calculate the IHD. I've included the equation here to reference. So I'm going to take 0.5 and multiply by 2 times the value of carbons, which is 4. Then I'm going to add 2 and subtract the amount of hydrogens, which is 8. And none of the other values are included in my number. So 0.5 times 8 plus 2 minus 8, this is going to equal 1. Now, here you would reference the IHD information and determine that a hydrogen deficiency of 1 could only be because of a double bond or because of a ring. Okay. Next up, we're going to take a look at these spin-spin couplings to determine what types of hydrogen environments we have present. So let's look up here first. I know that there are 2 hydrogens in this environment, so it's probably a CH2. The peak here, the splitting that's happening, is going to tell me what this is near. This is a quartet. N+1 rule tells me that there must be 3 hydrogens producing this quartet. So my CH2 must be near a CH3. Okay. Here I see there are 3 hydrogens again in this environment. So this is probably a CH3. But what is it near? Well, this is a singlet. Singlets are only produced when you are near no hydrogens. So it's probably just a carbon. Lastly, I've got another trace of 3, so another CH3. This is being produced as a triplet, which means we are probably near something that has 2 hydrogens on it, so a CH2. All right. Now, beyond this splitting information, what we can also look at is the shift information. So what I'm curious about, and you might be too, is what type of group is this single carbon with no hydrogens on it. I know I've got a double bond, possibly, or it could be a ring, but the fact that there are CH3s tell me it's probably not a ring, so it's probably a double bond. So I'm curious what kind of group is on this C. Is it a ketone? Is it an aldehyde? Could it be a ester? Or what? What do we got? So I look at this signal, and the shift of this signal is right about at 2. So let's look at table 27. So on table 27, a shift of 2, what I've got here is an ester. And the hydrogens that are being detected here that are near an ester show up at 2.0. So that makes sense. And you know what else makes sense about this is the fact that there are 2 oxygens in an ester group. And guess what? My molecular formula also has 2 oxygens. So let's see if we can start to put this together. I'm going to start by drawing the ester. And I'm going to draw it just like it was on the chart here. So I've got my oxygen over here and then my carbons over here because that's the specific group that's producing the 2.0 spin. So got my oxygen here, and then my information from my spectrum here is telling me that near the C is a CH3. So near the C must be a CH3. Okay. All right, so the other information that I can see is I've got some sort of CH3 near a CH2. That must not be this CH3, it must be a different CH3. And I've also got a CH2 near a CH3. Oh, how convenient. So let's finish this off. I must have a CH2 and a CH3 here. And let's double check to make sure that my atoms I'm using match up with my molecular formula. I've got 1, 2, 3, 4 carbons, check. 2 oxygens, check. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. That works. Also, how many environments do I have? I've got 1, 2, 3. 3 signals. And again, I've got a CH2 near a CH3. That would be producing a quartet. I've got a CH3 near a CH2. That would be producing a triplet. And I've got a CH3 near a C, which would produce a singlet. And that singlet has a shift of 2 because it's near the ester. So this is our final answer, our structure. So good job. The next thing I'm going to have you do is watch my 3rd video on the assignment I'd like for you to do in class. Thanks for watching.